Hello, are we recording? Yes, we are. Marvellous. Okay, so I'll jump right into it. I don't know when it was. I think it was roughly November of 2019. I went to Barton on Sea, uh, and there is quite a famous locality there called the Barton Beds. So famous, in fact, that there is a stage of the Eocene, the Eocene being one of the main periods of Earth's history, um, called the Bartonian, named after Barton, correlating to roughly 40 million years ago. And this is world renowned. So everyone in the world knows that the Bartonian correlates to 40 million years ago and correlates with Barton upon Sea. And I collected some fossils there. Fun fact: those that journey destroyed 2 pairs of shoes. um, So today I've started identifying them to species level if possible, but as you'll see, it's not always possible. And this is a big bag of what looks like nothing in there because it's mainly covered in the actual clay. So I've had to wash that off with fingers and brushes and hot water. And now we're going to go through the first 11 fossils of what there are. So the first one is this. It's a bit of petrified wood. Honestly, not that special, but I figure it's probably an angiosperm, so like the main types of trees you'll see today, because the angiosperms, as a clade, as a group, originated in the Cretaceous, sort of 70, no, older than that, probably like 100 million years ago, roughly. And as such, just probability dictates that this is probably an angiosperm. It's not especially interesting. So this one is number 2 in my notes. There we go. I probably won't focus, but it's a little shell, little gastropod. So the same group that includes snails and such. This is a marine snail. This is a marine deposit. This wood, number 1, probably would have washed in from a nearby forest or something like that. But the majority of these fossils will be found in the ocean, and as such, this is an ocean deposit. So this one is definitely the genus Horstata, but it's contentive as to whether it's Horstata editus or Horstata, sorry, I'm reading my notes, conoideus, because it doesn't feel big enough to be Horstata conoideus. However, it could be a juvenile, and it doesn't feel fluted enough in its edges to be Horstata editus. However, that could be a taphonomic remnant, so how it's been preserved or how it's been bashed about whilst fossilizing, things like that. So yeah, that's that one. This one is quite a big one. This is called Hippocrenes. I think it's Hippocrenes amplus. But what's interesting about this is that this is only a tiny remnant of it. The actual thing would have probably come up to about here. And it's interesting because I've never dug at the Barton Beds before. So when I found this, I was like, oh, that's really cool. And then the person I was with was like, no, that's a terrible Hippocrenes, because normally you get the big bodies and the apertures of the shell, which are so much bigger. So, but I think it's quite neat. The next one is a type of gastropod called a scaphopod, and I think they're extinct today. But they're just little tube things. They just look like a white tube. But here is the aperture, and a tiny little squid thing, well, snail thing, would come out the end here. Tiny, and they would burrow into the sand. And they would, on the top, it's theorized they had sort of chemophores to check for like disturbances in the sand and stuff like that. And yeah, this is Dentalium bartonese. And then I have more wood. I'm only going to show you a couple more things because this is already really long. But I've got a bit more wood and a, some more shells. This is just the idea of the average fossil you'll find. It looks like nothing, and believe me, it's nothing. Nothing identifiable anyway. In my notes, I've just called it shell fragment unidentifiable. It's a gastropod, I know that much, but aside from that, there is no way you can tell what that is because there's no detail and it's not complete. This one is interesting because it just looks like a little pebble. And until see those little holes, this is what we call a trace fossil. So the actual rock is just a rock. However, this would have been at one point a ball of sand, something to actually grab onto and burrow into. And as such, these holes are remnants of where an animal has burrowed or even eaten some of the sand and digested it. And as such, we call it, well, it's dubious. I think it's called nathickness, which means mouth trace. So it's where something has got its mouth on the sand, chewed it up, swallowed it, whatever. But it could also be skelethos, which is a burrowing trace. And I just thought that was interesting because normally it's just a bit of rock, which wouldn't be interesting. But we can see remnants of where life has been on it. And then the last one is this one, which is, I think it's Fusilis. What's interesting about this is it just looks conical. I'm holding it the wrong way. It's conical, kind of like nothing. Nothing interesting. Until you realise 60% of the specimen is missing. Because Fusilis is known for having a big, long umbilical, which is, so this is the umbilical of a shell, the tail end of it almost. Fusilis has an umbilical sort of down here, really long, really, really long. And the only way you can tell it's Fusilis is the indentations. If you can see, the indentations and the markings on the shell go a certain way, and that only happens in the genus Fusilis. And you can figure out with the relative lengths and the aperture size. I think it's Fusilis perectus, the species name. So if you know where to go and where to look for, you can find things to species level. I think that's really cool. So that's all I've uncovered today. No vertebrates, which is annoying, considering I'm primarily a vertebrate paleontologist, but I know there is at least one pycnodontid little fish tooth in that bag, but I have to, unwrap it, unravel the clay and shit. But I hope this wasn't too boring. I hope it was interesting. And yes, that's part 1 of Lewis is a Nerd. Thank you.